Hello everyone. Today I'm gonna go training you on making some metrics using the definition of list. So far we have learned how to use list, how to make arrays within the list. Now I'm gonna go through making some metrics and doing some algebra within the metrics. The way that we are gonna do this today is just by using list and sublist by the definition of the list through that. And you know that matrices have rows and columns. So the number of lists that you have will show you the number of rows, and the number of elements within each list will give you the columns of that matrix. So for example, if I want to define a 3 by 4 matrix, I should write matrix equal to, by the definition of list, it should be through brackets. And within these brackets, I should have 3 rows. That means that I should have 3 lists. So here the first, the second, and the third. And then within each list, I should have 4 columns. That means that each list or each row should have 4 elements. For example, here 1, 2, 4, 5 for the first row. For the second row, I will have 2, 0, 4, 5. This is the second row. And for the third row, 3, 4, 1, 0. So now I will have a 3 by 4 matrix, and if I return the matrix, I will get this as the definition of the matrix in here. You should be notice that the number of columns for a matrix should be the same for all of the rows, otherwise it's not a matrix. So when you are writing a list and the sublist within that to make a matrix, you should be very careful that the number of elements within it each sublist should be the same. Another method to define the matrix is not by having all of them in one line. So you can add a comma and then go to the second line and then define the second row and then to the third row and so on. So here you can kind of see the matrix formation, but then if you recall that, you will see you'll get the same thing as before. Then to recall all of these elements within the matrix, we should have the syntax of having like ing as we have in other languages. The first one is the index number for the row, and the second number is the index number for the column. So here by writing matrix 0, which shows the first row, and 0, which shows the first column, you will have index 0 and 0 within that matrix. Also, for example, for the second row, second column, I should write matrix 1 and 1. So let's go to do some multiplication within the matrix. So let's define the first matrix with 1 row and 2 columns, and the second matrix with 2 rows and 2 columns, and see how the multiplication within that matrix happens in here. So here, since I have 1 row, so I just need 1 sublist. Remember that to define a matrix format, you should definitely have sublist. You cannot have all the numbers within the main brackets. That won't make any matrix for you. It's just a list, it's not a matrix. So in order to have a matrix, you should have sublist as rows and subelements as columns. So they must be within a sublist. So this is M1 at the matrix 1, and then we can recall all of its elements. For example, first row's first column by just having M1, 0, and 0, and first row, second column, M1, 0, and 1 as the second elements of the first row. The second matrix is a 2 by 2 matrix, so I should have 2 sublists for the rows, and I should have 2 elements for each sublist as the columns. So we first should define M3 as the answer of this multiplication. And as we know, it has one row and two columns. We cannot just leave M3 as a void list. I should define the number of rows and columns within that matrix. So I should first put a sublist as the number of rows, and then within that sublist I should define the columns. So I should have another pairs of brackets, comma, and another pairs of brackets as the columns. Now the answer will be 1 by 2 matrix. Here we can again check that if it is the matrix or not by going through its element, for example M300 and M301, and that means that I have the two elements and everything is defined perfectly. And then by the definition of the matrix multiplication, we can assign each elements of M3 by multiplication of the elements of M1 and M2. Then we can have the first element of M3 as 9 and the second element as void, which is still doesn't have any value within that. So next we should define the second element by the definition of the matrix multiplication by using M1 and M2 elements. And finally we'll have the matrix multiplication. Now we'll have the final M3 as one row, two columns with the elements of 9 and 12. But remember that the way that I am doing in here is just for clarifying the multiplication and using the matrix. But later you should write a for in loop to make that easy and repeatable for a long and large matrix and do the algebra within that matrix for an easy for in loop.